So we had a pretty long weekend with the snow day here in Houston, so I had lots of time to CAD. I did make lots of progress on the elevator, so I'll just go one by one. The most detailed part of the elevator was the carriage, which is the smallest rectangle. And yeah, this is basically finalized. It's the way that it works is the same way as the rest hounds did. I just made changes to make it more compatible for us. So the dimensions of the actual carriage are the exact same as the ones that we made last Saturday. The only difference that I did in terms of assembly was the fact that I noticed that they used the max tube end cap and a lot of screws, and here I have gussets, which I didn't like the way that Rev put all their stuff together, because I realized there were like at least 6 screws a corner, and that just seemed a bit excessive for me. So I went with like just the regular gussets that everyone else uses. A big change was this pivot plate. Carl made a good point about beefing up the plate a little bit. The original design had one screw or one bolt to hold the dead axle in place, which wasn't ideal. So I made it bigger and made it work with the thrifty hub. So now we have like 7 bolts on each side to secure it. I also made these hard stops wider. I had issues with the belt interference. Again, that shouldn't really change much. And then I also changed the way they did holes back here, because the rest ones had a lot of like really weird holes. But for me, I was just prioritizing making sure we can mount this. So I just made it more compatible with max tube and put the max pattern on there. In terms of the motor mounting, this also changed a lot. Basically what I did compared to the rest hounds design is I rotated it 90 degrees, and so you would mount the screws in from the side. I did this because I thought and for like servicing, when we inevitably need to take this top motor apart, this would be a lot easier than trying to get threading a screw through the tube and making sure the spacer is lined and then making sure the hole is lined. So I just thought this would be overall a lot easier. And yes, that means we need to manufacture this plate, but then again, it's kind of just a rectangle with some holes, so it shouldn't be that big of a deal. I also shifted the motor position. On the rust hounds design, they had their motor all the way over here, and then had that big 3D printed pillow. So I just tried to shift it to where the output shaft of the motor and the whole arm assembly is close enough to the middle. And yeah, that's basically what I did. And a difference between an interesting thing I saw with their CAD is that they said they had a 75 tooth belt, but when I tried to put in a 75 tooth belt, it was quite a bit too long, and actually a 70 tooth belt was basically perfect. So I don't know what happened, whether that was that was a mistake on their side or something, because I checked the pivot points and the distances are all the same. I'm using the same pulleys, but yeah. So that's a pretty big change, as a 70 instead of a 75 tooth. The actual arm itself, I didn't touch. It's basically the same as the one we have. Everything's the same. The only difference is the wheels. We have thrifty squish wheels. They have green compliant wheels. I think that's about it for this. So here I did like spacers to do this, but realistically you can just put 2 shaft collars on either side of the arm and it'll do the exact same thing. So we can do, there's so many ways we can do that. So yeah, it's lacking some detail in that aspect.
So how is it connected to that hub? I see the 48 tooth hub, and that's driving the arm, but how does it connect?
So you would just need to use long screws. So there's holes. The holes that align are these ones. 1, 2, the ones on the bearing block, and they align with the holes of this pulley. And so you would just use like a 3-inch screw, I think.
A 3-inch is not bad if that works.
Unfortunately, it's a kind of long screw, but it's not too bad, so it shouldn't be a big issue.
So there's not a pill block or anything there in between.
I didn't like I don't know why they had to make that giant 3D printed block. That seemed kind of silly to me. But yeah, so this is a solution to that. Yeah, this is the carriage. I don't suspect any major changes unless we have really big issues. This carriage is going to stay mostly final. So yeah, and then now another thing that I did was I kind of created basically three elevators over this past 3 days, and it's just differences in how they kind of rig up together. The first one, so we looked at obviously the Rust Hounds one, and then the Rev Max Lift, and we were kind of debating on which one we should follow closer. And I think I found a good balance that kind of takes some aspects of both, but still but still keeping it relatively simple. The one that I like the most personally would be this one, which is as close as the Rust Hounds elevator as I could kind of get. It still implies the principle of you have a motor down here, and then a chain and sprocket would connect these two, and then drive. These would be pulleys, and then it's going to be rigged up exactly how the Rust Hounds do it, here, down here, terminating over here. And for the pulleys, I was thinking of doing fully 3D printed pulleys, and then I talked to Sid, and then he was like, and then he made a good point of you could just drill a hole through the hex shaft and then just push the rope through that and then secure it like that. So I thought that was a pretty neat idea. So yeah, and then we would really just need to 3D print these cones, which should be pretty simple. They just slide onto the maxi and make sure the pulleys are straight. And yeah, we're still working on I still need someone to work on a solution for this. So if you're free, go for it. Let's look at the other elevators. This one was the kind of a hybrid between the Rev and the Rust Hounds elevator for the load. And okay. So yeah, you can see it looks kind of similar. The big difference is just how they all drive together. Really, it's just it's the same thing, kind of flipped horizontally. But the problem arose. The reason I kind of strayed away from this was, if we were to make the spool of rope down here, we would need to stretch it this way, and I didn't like that. You would need to probably add another bearing here, and that would add more complication. And then to attach the elevator, you would use, I thought you would use this gusset, which you can have chain interference there. So I just kind of, it's basically the same elevator, just the way that it's attached is kind of rotated. But yeah. And the reason I strayed away from the Rev one was because I realized that if you want to use chain on this first stage, you kind of force yourself into there. I don't think there's a way that you can make an elevator that runs the first stage on chain, but still make it continuous. So I realized that as soon as I added this, which was kind of unfortunate, but yeah. And then I did finally put together everything with the reef. So here is bumpers on the reef, and this will work. Yeah, there we go. It's kind of slow to manage, but if you do it carefully, I don't know why this is. I guess maybe in the Rust Hounds did say that their CAD was kind of approximate, because they kind of just, a lot of their stuff is they built it and then use a measuring tape to just measure. So a lot of it isn't exact. But yeah, this is how it would work. And of course, this is something that we're gonna have to tune, like with software, where we need to determine where is our best angle and position for each level. So I do L4, and then you'll see that it works on L3 and L2. But yeah. So yeah, these past few days I've kind of just been knocking as many details as possible onto the elevator as I can. So I realize that's the probably the most critical part of this robot. And yeah, that's what I've been working on. Additionally, I did last night add in some electronics, just like the critical stuff. So yeah. So here would be the battery. I used Benji's plate design, and then once I put it in, I saw where all the good holes are, and then just kind of optimized the design to make it work. And then I didn't know if anybody sold the part where you can put the Anderson clip. If they did, that would be nice. But this is just a custom piece of plastic they can just bend. So I'm not too worried about that. Here is the breaker. So I'd have one of these wires would connect to the breaker, and then one of the breaker wires come down here. So I think this should work, but I'm not 100% sure. And then you have the PDH, and then the Rio's right here. And yeah, this shouldn't really be affected by the algae intake because it's below everything. So yeah, it would be nice because it's kind of on the open side of the robot. So if you ever have when we inevitably have issues, it'll be easy to reach in there and resolve those issues. Yeah, that's I think that's about it. Everything else has stayed mostly the same and untouched. So, yeah.
I think you should put the breaker closer to the outside, maybe on that
On
tube
this
line.
rail.
Yeah,
Yeah. Okay.
Yeah.
because an inspector might say that's reaching into the robot too much.
Okay.
Because imagine there'll be like battery wires coming up,
Yeah.
and those might make it people more hesitant that they can reach their arm through there and turn it off. So we just might have to add some cover or something to make it where it's not easy to turn the robot off. But yeah, something like that. I mean, if you're clever, you could put it on the battery itself. It could all be just one big thing. The battery holder, that plate. You could maybe attach stuff, but that plate, I guess we're just cutting that, right? So if we just extend the plate out, we could just literally have a battery. I'm not sure how the wires would look. So,
Worry about it was how because I realized the battery wires are like the really thick ones, so they can't really bend. So I tried to make it. It still didn't look great, but I tried to make it to where they don't bend as much. Yeah. Yeah, we can definitely just move this and put it on this 2x1. It shouldn't be a big deal.
I mean, if you're clever, you could also put your battery connector. You could have like an integrated little battery thing that holds the battery, has the connector, and has the switch. So when you take it out, it's just one big piece.
Yeah.
I don't know. We'll see. That's something someone could play with. I think it's a good activity for someone to mess around in CAD. I don't think you need to do too much here right now, Cedric.
Okay.
It might be good for anybody else who's interested in doing some CAD to play around with some ideas on how to change the orientation of some of these things, make them easy to manufacture. Because the battery connector right now, that's a little tricky to manufacture. I guess we could cut a piece of big angle and do something, but yeah, that's probably the only way you would be able to do it is cut it out of metal. So we would not 3D print that part. It would take too much force. So going back to the carriage with the pivot point, it seems like we have a lot of these pieces. Is it possible that the plate that we've already laser cut has the approximate same spacing between the arm joint and the motor? Is that
The spacing between these two pivots are the same. It's just this got thickened by a lot, and I think Les already printed some new plates, so we can just use those.
yeah, I guess the question is, I would like to know if we printed this pulley system, and tested the belt, that would give us a lot of confidence that everything is correct. So that's probably a really good test we need to set up to make sure we have the right belt and that the spacing actually is going to fit. And we can, I guess, use 3D printed parts. It doesn't matter to me, as long as the spacing's right. So.
Yeah, I've got also printed 24 tooth, and I'm going to print the 48 tooth,
Okay.
the thrifty bot. So we should probably be able to put everything together. And I don't know, I think since it's all together, it may not be as CADed, but we've got kind of everything in the right place, I think. So, I mean,
Cedric, I wanted to point out also that if you kind of look closely, the space between that, I guess those blocks you have over the 2x1 and then the 48 tooth pulley, there is a gap, right? So if you torqued screws, it would be putting a little force. You probably want to have something that fills that gap. Does that make sense?
Just like a little spacer.
So if we're going to print the pulley, maybe we should print the pulley to fit over the 2x1, or some sort of combination of that bearing block with the pulley. That way we don't have to worry about the gap or how it all connects, possibly.
Try to print it with like something like some sort of spacer that extends a little bit more. Because I would be hesitant to make something that would print all the way until like here. So I feel like that would break almost instantly. But we can like just throw a spacer in there, I think.
we could put a ring, like, basically the 48 tooth has a ring, so we could put a ring that would just fill up the area in between.
Yeah, it could.
So,
Maybe
yeah,
we just print a ring that fits in the
that
gap.
same spacing. Yeah, I think
That's
so,
fine.
because when you tighten it, Andy's right. You have to be careful when you tighten them to kind of tighten them in the same order, so that it's not, it doesn't tilt and stuff like that. So the having something in between would make sure that we don't twist either the pulley or the arm. Yeah, good. Yeah. Okay, and there's a bearing block on each side of the arm. So there's a half-inch hex bearing on both sides of that, right?
Yes.
Yeah, there's one on each side. Okay. Yeah.
I don't understand why you have like a hub at the end of that shaft on the arm pivot.
This was mostly for reinforcement because now we have 6 plus the center one to make sure the shaft is there. So the whole idea there was to just reinforce the arm and make sure that it doesn't. It's going to take a lot more to break this now.
I see.
We have a lot.
Because this is what's called a dead axle.
Dead axle. Yeah.
And before, I think in the rust hounds, they literally just put a screw. They just tapped the end of the shaft, and they just had a fixed shaft going for the arm, right? And so you're talking about having something that's a lot more solid than just a screw.
But it's still a dead axle. Is just more screws. So yeah.
Okay. That seems a little overkill, but yeah, I guess we probably could just 3D print that. I mean, we wouldn't put a metal one, right? Is that what you're thinking?
Well, I don't know. I just thought it was something. One less thing we have to make, and if we have more of them on hand, that would be nice. But yeah, it doesn't need to be the thrifty hub. It can be like something else that's more strong.
Yeah, I think adding a metal hub just for a little more reinforcement, I don't know if it's necessary. We want to be a little careful about weight, but yeah, I guess it's fine. We can think about it a little bit more too. So. So I'm trying to understand the uh, brackets that you want in there. Why don't we want to use the rev stuff? Are you just worried about weight? Because don't they have, like, if I remember looking at when we assembled it, it has plastic spacers in there that we could put through bolts, uh, as like end
Yeah,
caps.
I kind of like I mean, the red stuff does work. It's like it may not aesthetically look great, but it's already together. So I'm not sure why we need to redo it.
The idea of having those long bolts that go through like two
I,
tubes.
I don't think it does. I think it's actually they have uh, the end caps, so it just goes into the end cap, and we can take them off and put them back. Versus if you kind of rivet things, and then we have to drill them out and put them back on too. So I don't know, like uh,
Yeah,
the
I
preference.
think
It's
making
not.
these gussets is going to be kind of not as much fun as just putting together the rev stuff. So I think we should maybe look at using what we have, at least for the carriage side of it, because I mean, Les threw that thing together on Saturday in like what 10, 20 minutes with just bits and pieces, and it looked square and
Yeah, it's really tight, and I do like. Yeah, I do like that it doesn't move. It basically it maintains the square, and in the past, our carriages have been skewed, and you don't want skewed. So I mean, it's maybe overkill, but that overkill means you can't, you know, if it's not even on the force going up and down, it'll still stay square. So I mean, overkill sometimes is good. Yeah,
yeah, we don't want a parallelogram for this because it'll create a lot of problems as it goes up and down. So
yeah, rectangular. Yeah,
and our build quality is suspect sometimes when
yeah,
we put together these gussets. So we end up with a parallelogram, and then it
yeah.
becomes a problem. So, but yeah, I like this design. I'm happy
Yeah,
with it.
yeah.
So
Did you use the flush mounts on the inner stage and the outer stage too? Like just like this? Yeah. Mm-hmm.
Oh, so on the inner stage, I did the same face mounts,
Face
and
mount.
then
Okay.
I did end mounts on the outer.
Okay. All right. That's good. Yeah, that's good.
so
And do we
where are
know
we
what?
getting the pulleys? What,
These are from McMaster.
okay, so
Y-
those need to get ordered pretty quickly here.
I would say so. If we're happy with it, yeah.
Yeah. And Andy, didn't you order some pulleys from? I think you had 10 pulleys from
From Rev.
Rev. Yeah. So yeah, yeah. Take a look. But yeah, good.
Well, I don't think they're as big as these pulleys, and
Okay.
it seems like I don't know how the string is going to route around here. So what can you kind of like just drag your mouse around of where you think the string is going to go? Maybe I don't
The
know.
pulley, the string is going to start here, and then it's going to go up here,
The pulley.
around this one, and come back down, wrap around this one, and then wrap around this one, and then there's going to be a termination point here. I haven't counted the termination point, but I have it in mind. I can pull up the rest house thing because I have some photos of it.
Well, I think you should modify your motor mounting plate to have a little termination hole or something that you can tie in the string to.
Or we could actually have one on the top because we have to have one in the middle going down too, since it's continuous.
Yeah, yeah. I mean, look at some ideas on how to make that, and we could make that plate be one for termination as well.
I remember looking at this a bunch. But I did notice they had a
There it is. Yeah. Yep.
Yeah, it just starts from the bottom shaft, goes up, goes back down, goes back here, and then terminates. And then this is the one they have. They catted it. They showed in the middle, but they said that they built it further to this side to accommodate the funnel, the note, or the coral. They just moved it left. They just catted it in the middle so you could see it better. But they moved it to the left in the actual build.
Does it make sense to hold on? Go back to that termination. Does it make more sense to terminate in the middle at the top?
There's two sides, left and right on.
Oh yeah,
So
the
Oh,
really
this is
long.
just one side. Oh, I see. I see. Yeah, yeah. Okay. True, true. Okay, I got it. And they don't use any sort of springs?
Yeah, I don't think they do. It's just pulleys, and this is how they terminate it on the carriage.
oh, good. Yeah.
So you have they had a bolt that just went through the whole tube, and then have a little a half-inch shaft, and then however you choose to knot the rope, and you have a sandwich of washers where that rope is.
How do they tension it?
I don't think we heard the question.
How do we tension the rope? Is there a turnbuckle in there somewhere?
I haven't quite figured that out yet, but
Because I know we're not going to get it right first shot. So
Yeah, I mean, we could have a turnbuckle right where they're doing that attachment point, and that we could adjust, and then have another connection. But we'd have to think a little bit about that.
or maybe on the return end of the line.
Yeah. Yeah, so I think Rev has a turnbuckle if you want to see what one looks like. They have like one that's for chain, and then they have one that I think is just a pretty standard turnbuckle. We should have something pretty similar to it. So, yeah, I would look at adding that. I think that's a good idea.
Yeah, actually, I think I saw one where they actually had kind of a spool. So at one end, it's kind of like that hex thing, but you could turn the hex thing around with a wrench and then tighten it again. So it was like even the end would kind of wrap around. Instead of like just poking out, it was like almost a little spool. So it would end on a spool, which you could crank around. I don't know. I'll see if we can find that.
Now, if we get really clever, we could also have a spring system in there as well. But maybe we'll table that for now.
Yeah.
It depends on if we need the extra buoyancy, the support.
Yeah.
have we figured out what rope we're gonna use for this? Because I noticed the orange rev rope that you bought. That's like really thin. I've seen the other ropes I've seen is like an eighth.
Yeah, I've got an eighth also. I think that 0.12 millimeters is an eighth. Also, 1.2 millimeters is an eighth. So, I mean, but everybody uses the eighth. It's part of the Thrifty Bot kit.
Yeah, and people run much heavier elevators than we're running, so I think we should be okay.
Yeah.
Okay, yeah, this looks good. Does anybody have questions? I know this has been the Cedric CAD show, but it might be good to ask other questions if people have them. If not, maybe we'll move to programming. Unless there's something else you want to talk about, Cedric. I mean, it seems like you just need to keep making progress. You're getting close to have a completely done CAD. So.
Where should I go from here? After I make the necessary changes in the elevator, what should I CAD next? The pivoting funnel probably? Or the intake? Or the algae intake?
I think you should put the climber and the cage in to make sure everything fits.
Yeah.
So
Yeah.
throw the barb, throw the actual climber stuff if we're getting the EveryBot kit, and make sure all that fits.
Yeah. And just have it sideways, right? Over the, yeah.
And then put a cage in there just so you see where it all comes.
Yes. Because I think that's right, because the algae intake, I think we'll find something depending on how much space we have. Well, yeah. Yeah. Cage will be big.
The nice thing is that I feel like we could change where the elevator is mounted slightly if we needed a little more space.
Just
Because I
move
was
it up a hole.
Yeah, because I was thinking about like the constraint right now is the coral. It goes to the edge of the frame perimeter, but we could have something that allows the coral to kind of go over the bumper, and then the elevator can just move forward, right? If we need it. Let's see how everything fits.
Yeah.
But yeah, once you have the climber in, I mean, just keep going. Let's get as complete as we can. Um, Make sure that the elevator is going to fit with everything, and then we can maybe start looking back at the algae mechanism. So. Any other concerns? I think we'll move to programming then.
Do you think the